Okay, so here's a scenario with vector equations of lines. We've got line 2 and line 3, and we're going to look to see what type of relationship they have, whether they're parallel, skew, same line, or intersecting. In order to do it, I'm going to rewrite these equations. I'm going to call line 2, I'm going to set it up so that it is x, y, z equals 1, 0, 3, plus a t, negative 1, 1, oh, negative 2, negative 2. Okay. And line 3 is going to be x, y, z equal to 1, negative 1, 4 plus u, 2, negative 1, 3. Okay, so my choices are, for possible scenarios, I can have parallel or same line. In order to check for this scenario, I look at my direction vectors, and if they are scalar multiples of each other, and then I know it's this scenario. These are not scalar multiples of each other, so neither one of these will work. The other two choices are intersecting and skew. And so in order to do it, if they're intersecting, it means they share one common x, y, z coordinate. So let's see if we can find what that value is. So that means I'm going to set up equations here. So my x value is 1 minus t equal to 1 plus 2u. My y value is 0 plus t equal to negative 1 minus u. And my z value is going to be 3 minus 2t equals 4 plus 3u. I'm going to rewrite these equations now. This one I'm going to have negative t minus 2u equals, subtract the 1, 0. Here I'm going to have t plus u is equal to minus 1. And then finally, this last one will be negative 2t minus 3u equals 1. Okay, and so I'm going to take my x value and my y value, equation 1 and 2, and I'm going to solve for t and u. To do it, the easiest way is to use my calculator. And I'm going to use my calculator and go to apps, go to my apps, 3, which is my polysmalt. I'm going to go to number 2. I have two equations, two unknowns. I'm only going to use 1 and 2. I'm going to solve the equations and then test it into the third equation to see if it works. So I have negative 1, negative 2, 0, and 1, 1, negative 1. And then I'm going to solve. And when I do that, I get my t value equals negative 2, and my u value equals 1. Now, with this, what I'm going to do now is I'm going to take these and plug them in to here. So it's minus 2 minus 2 minus 3 times 1 equals 1. That's what we're looking for. So this is 4 minus 3 equals 1. A true statement. So what are the implications of that? The implications are simply that this t and u is the same t and u works in all three scenarios. So this is a scenario where I have x, y, and z in common. So therefore they are intersecting. To find the point of intersection, I take either t or u and I plug it in. So let's take line 2, x, y, z, which is 1, 0, 3. Plug in my -2, -1, 1, -2, and do the calculation. 1 plus 2 is 3. 0 minus 2 is -2. 3 plus 4 is 7. So their point of intersection is 3, -2, 7. If I would have taken this u and plugged it into here, I would have ended up with the same point.